All right, we're going to learn how to compare and order rational numbers. So remember, rational numbers are numbers that can be written as fractions, and that includes the whole numbers, and that includes the integers, and it also includes all the other kinds of numbers that don't fit in the whole numbers or the integers. So 0.8, that's a rational number. 1, that's a rational number. -5, that's a rational number. So we're going to learn how to order and compare these, just like we did with the integers. All right, here's our steps. So how to. Step 1, you're going to convert all numbers to the same form. You're going to convert them all to decimals or all to fractions. Decimals is going to be the easiest. Okay, and then fractions, you have to make sure that they have a common denominator. Okay, common denominator. Now, with the fractions, the common denominator, that's going to be a little bit tricky. You know, you may not always be able to get a nice and neat common denominator. So going with decimals makes it easiest. Step 2, use a number line or place value to order or compare the numbers. If you're going to use place value, you're going to line the numbers up using the decimal point. And y'all have done this before, but only with positive decimals. Now we have to include negatives because we're doing all rational numbers. And then you can also use the number line like we did with our integers. You're going to have to plot the numbers, and then you read left to right for least to greatest, or right to left for greatest to least. I always kind of remember that by thinking left is least. Okay, so if you want least to greatest, you start on the left. If you want greatest to least, you got to start on the opposite side, which is the right. So wherever the L is in the ordering you're looking for, so least to greatest, the L comes first. You're going to start on the left. Greatest to least, the L comes second, so that means you need to go from right to the left. Okay, those are the basic steps. Next here, reminder, if you're going to convert a fraction to a decimal, you have to divide the numerator by the denominator. So let's do an example. We want to convert 3/4. We're going to divide the numerator, 3, by the denominator, 4. The number that is being divided goes inside, guys. I have seen this mistake too many times where y'all switch the thing that goes inside the division house there. Whatever number is actually being divided goes inside. The number that is doing the dividing stays outside. Got to remember that. An easy way to remember that is top dog in the house. When you look at a fraction, the top number is always going to go in the house. So just remember top dog in the house, and you will be able to get your fractions converted to decimals. So let's do this. Can 4 go into 3? No, we've got to put a 0. Put your decimal. Put your decimal here. Put a 0 there. Will 4 go into 30? Yes, 7 times. 4 times 7, 28. All right, 30 minus 28, that's going to be 2. Now, a lot of us I've seen going and writing some strange thing like 0.7 remainder 2. Guys, no, we're in middle school now. We have to keep going. Will 4 go into 2? No. So we can bring down another 0. Will 4 go into 20? Yes. 5 times. So what is 3/4? It is equivalent to 75 hundredths. Okay, top dog in the house. Top number goes inside. That's all you got to remember. Next, here's our first example. We're going to make sure we label this in our notes, example 1. And we are ordering from least to greatest. Step 1, We got to turn them all into decimals. So step 1, converting them all to the same form. 1/3, fraction to a decimal. Top dog in the house. 1 divided by 3. 3 will not go into 1. Put our 0 there. Put your 0 in your decimals. 3 goes into 10. 3 times. 3 times 3, that's 9. 10 minus 9 is 1. Will 3 go into 1? No. We can bring down another 0. 3 goes into 10 3 times. 3 times 3 is 9. Are y'all noticing a pattern here? Me too. This is going to be 0.3 repeating on and on and on and on. So 1/3, that's 0.333 on and on, or 0.3 with the repeating bar on top. 0.3, that's already a decimal. -1/5. For right now, we're going to ignore that negative sign, and we're just going to convert this fraction into a decimal. So 1, remember top dog goes in the house, divided by 5. 5 cannot go into 1, so we put a 0. We have to put a decimal. 5 goes into 10 2 times. 5 times 2 is 10. 10 minus 10 is 0, so we're done. So this is -0.2. You got to put that negative sign back on. -0.25, already a decimal. Here, 1/2. 1 divided by 2. 2 will not go into 1. Put your decimals, put your zeros. 2 will go into 10 5 times. 2 times 5 is 10. That's not what I wanted to do. Let's just start that over there. Sorry about that. Okay. 1 being divided by 2. 2 will not go into 1. Put your 0 in your decimals. 2 goes into 10 5 times. 2 times 5 is 10. And we're done. So it's 0.5. So now we have 0.33, 0.30. Notice how I'm making them all have 2 decimal places. You want all your numbers to have the same number of decimal places so you can compare them place by place. Here, this was -0.20, -0.25, and then 0.50. So we're going to start ordering these. We want to go from the least to the greatest. Least to greatest. So remember, least, you're always going to start with your negatives. We have -0.20 or -0.25. Remember, with negatives, they are the complete opposite of positives. So for the smallest number, we want the largest looking negative. So between -0.20 and -0.25, -0.25 is the larger looking negative, so we know that it is actually the smallest number. So -0.25 is my smallest number. Cross that off the list. Now again, the negative. Our negative is going to be our smallest one, so -0.20. Cross that one off the list. Now we're going to go to the positives. So we're going to look here. We got 30, 33, and 50. Of these, 30 is the smallest, so 0.30 comes next. Cross it off the list. Then you got 33 versus 50. Who's smaller? 33, so 0.33. And then finally, we have 0.50. Now we have ordered these, but guess what? This is not our final answer. We have to convert these back into their original form. So -0.25, that was its original form. -0.25. -0.20, that was originally -1/5, so we're going to have to rewrite that as -1/5. And your negative sign goes with the numerator. 0.30, that was originally 0.3. 0.33, that was originally 1/3. So we're going to write that back as 1/3. And 0.50, that was originally 1/2. So this right here is our final answer. Okay, next example. We got to use the inequality symbols. Remember, guys, these are inequality symbols. Okay, inequality. We're going to have to compare. Looks like we got an extra one here of this. So let's delete that. Okay, so now we will go back to solving here. We're going to have to turn everything into a decimal or everything into a fraction. Again, I'm just going to go with decimal because it's easiest. -1/8. We've got to divide that. 1 divided by 8. 8 cannot go into 1. Put your zeros. 8 goes into 10 one time. 8 times 1 is 8. 10 minus 8 is 2. 8 will not go into 2, so we have to bring down a 0. 8 goes into 20. 2 times. 8 times 2, that's 16. 20 minus 16 is 4. 8 will not go into 4, but it will go into 40. 8 times 5 is 40. And then we're done there. So this is really negative 0.125. Negative 0.125. Now we have to compare. Remember, with the negatives, the larger one is the smaller one. So the alligator doesn't want to eat the smaller one. He wants to eat the bigger one. So the alligator is going to open up towards the negative 0.125 because it's a smaller negative, which means it's greater. Here, -5 versus -8. Again, the smaller negative is the bigger one. So -5 is the greater one. 0 versus -6 divided by 3. -6 divided by 3. We have to see what that really is. 6 divided by 3 is 2. So this is -2. 0 versus -2. 0, always going to be larger than a negative. 4/6. Let's turn that into a decimal. 4 divided by 6. 6 cannot go into 4. Put your decimals. 6 goes into 40. 6 times. 6 times 6, that's 36. 40 minus 36 is 4. Put your 0. 6 goes into 40. 6 times. Y'all can see this pattern, right? That's 6 repeating. Over here, 0.6, that's 0.60. So 0.66 versus 0.60. Who's larger? 0.66. All right, so that about wraps it up for this. Remember, if you need to go back, you can watch the examples over again. Go back to that first slide and really go through those steps. Following those steps is going to help you to be able to solve any problem of this kind.